Hello, curious minds. Today, we're diving into a mind-bending discovery in physics that could potentially explain one of the biggest mysteries in the universe, the Fermi Paradox. You've probably heard of dark matter and dark energy, but have you ever heard of dark oxygen? Yes, scientists have recently uncovered hints of a phenomenon they're calling dark oxygen. It's a type of oxygen that behaves differently from the stuff we breathe, and it's leading us towards some fascinating ideas about life beyond Earth. Stick with us as we explore how dark oxygen might just be the missing puzzle piece in our search for extraterrestrial life. To understand dark oxygen, let's break down some basics. Oxygen, as we know it, is essential for life on Earth. It's a part of water, fuels our cells, and plays a key role in biological and chemical processes. But dark oxygen, on the other hand, is thought to be a form of oxygen that exists in environments with extreme conditions, possibly deep in space or in the atmospheres of exoplanets. Unlike regular oxygen, dark oxygen doesn't emit or absorb light in the same way, making it almost invisible to our current detection methods. This elusive nature is why it's referred to as dark. If dark oxygen exists, it could mean that oxygen-based processes may happen in the cosmos in ways we haven't yet considered. So, how does dark oxygen tie into the Fermi Paradox? The Fermi Paradox essentially questions why, in a universe so vast, we haven't encountered any signs of extraterrestrial civilizations. Scientists have proposed various theories, from the idea that advanced civilizations self-destruct to the possibility that intelligent life is simply extremely rare. But dark oxygen introduces a new perspective. If life can exist using dark oxygen in extreme environments, it's possible that life is more common than we think. It's just hidden from us, thriving in forms we cannot yet observe. Perhaps extraterrestrial civilizations don't rely on the same biochemistry we do, making them undetectable by our current technology. Life on Earth is resilient. It can survive in acidic springs, under crushing ocean depths, and even in radioactive environments. This resilience suggests that life could potentially evolve in environments that are vastly different from what we consider habitable. Dark oxygen could thrive in such extreme conditions, places that would be inhospitable to conventional life. By studying dark oxygen, scientists can gain insight into how life might survive under conditions beyond Earth's. This idea challenges our assumptions and expands our definition of what life-friendly environments might look like. Detecting life beyond Earth has been largely about searching for biosignatures like methane, water, and of course, oxygen. But if there are different forms of oxygen like dark oxygen, our search methods may need a complete overhaul. Current techniques might be overlooking signs of life on planets that are using dark oxygen instead of the normal kind. New instruments and strategies could be developed to detect these hidden biosignatures, potentially opening up a new era in the search for extraterrestrial life. Dark oxygen might be the reason we haven't yet found any life, because we've been looking for the wrong kinds of signals. The implications of dark oxygen extend far beyond the Fermi Paradox. This discovery might lead us to redefine what we consider as habitability and to develop advanced technology to detect elements and compounds previously invisible to us. If we start detecting dark oxygen on other planets, it could mean a higher likelihood of life across the universe, one that doesn't rely on the same chemistry we do. This could transform our understanding of biology and even inspire new, unconventional forms of life-supporting technology for space exploration. Imagine discovering a whole new layer of the universe's complexity simply because we've found a new way to look at oxygen. Before the discovery of dark oxygen, scientists had already encountered mysteries in the universe that defied conventional understanding, namely dark matter and dark energy. These dark substances don't interact with light and are invisible, much like dark oxygen. However, they have a gravitational influence, affecting the structure of galaxies and the expansion of the universe. This concept of dark substances sets a precedent for dark oxygen, suggesting that the universe holds many hidden elements that play crucial roles. Just as dark matter and energy revolutionized physics, dark oxygen could shift our understanding of chemistry and biology in space. Currently, space exploration missions prioritize destinations with detectable oxygen, water, and other familiar biosignatures. With dark oxygen, the search criteria for habitability may expand to include environments that were previously disregarded. For instance, icy moons or barren planets with no visible atmosphere might hold dark oxygen. Missions could start incorporating new instruments designed to detect signs of dark oxygen, allowing us to explore previously overlooked parts of the cosmos. This shift could broaden our exploration targets and possibly speed up the search for extraterrestrial life. If dark oxygen can support life, we might imagine forms of life fundamentally different from Earth's. Dark oxygen-based life could possess unique metabolic processes and structures adapted to extreme, low-light environments. For instance, rather than relying on photosynthesis, these life forms might draw energy from radioactive minerals or other unconventional sources. This concept opens up a whole new way of thinking about life's adaptability and could help scientists consider alternative forms of biology, giving new meaning to life as we don't know it. Detecting dark oxygen will likely be a challenge since it doesn't emit or absorb light like regular oxygen. Scientists are developing new detection methods that might involve indirect observations, like analyzing the gravitational effects or specific molecular interactions that dark oxygen might produce. Additionally, particle accelerators on Earth could help simulate dark oxygen under controlled conditions, allowing us to understand its properties better and creating a basis for detection in space. Mars and Jupiter's moon Europa have been top candidates for harboring life due to evidence of water and possible subsurface oceans. With dark oxygen in the equation, these locations become even more intriguing. Mars' deep caves, or Europa's ocean, hidden beneath miles of ice, might hold pockets of dark oxygen, supporting microbial life, or even more complex organisms. New space missions could be equipped to explore these areas with the specific aim of detecting dark oxygen, which could change our understanding of the habitability of our own solar system. When astronomers look for habitable planets, they generally search for Goldilocks zones where temperatures allow for liquid water. However, dark oxygen suggests that life might not need these strict conditions. Planets or moons once considered too cold, hot, or hostile could, in theory, support life if they have dark oxygen or other dark elements. This redefinition of habitability may lead us to reconsider many celestial bodies we had dismissed before. Could dark oxygen have played a role in Earth's early evolution? Some scientists speculate that dark oxygen might have influenced chemical processes on ancient Earth, potentially impacting the way early life forms developed. While evidence is slim, studying dark oxygen could help us understand whether life on Earth had roots in previously unknown chemical interactions, adding a new layer to our knowledge of our own origins. Quantum physics may hold the key to understanding dark oxygen's elusive nature. Just as quantum phenomena explain the behavior of particles in dark matter, they could explain how dark oxygen behaves under extreme conditions. Scientists might find that dark oxygen operates under principles of quantum entanglement or superposition, making it an intriguing subject at the intersection of biology and quantum mechanics. If dark oxygen exists, it could potentially offer new ways to harness energy in space. Some researchers believe dark oxygen could react differently under specific conditions, releasing energy that could be utilized by spacecraft. Future space missions might use dark oxygen as a resource to power deep space exploration, reducing the need to rely solely on Earth-bound resources. Studying dark oxygen might yield new insights for medicine on Earth. For instance, if dark oxygen-based organisms survive in extreme environments, they might produce unique compounds or enzymes that could inspire new medical treatments. Understanding how life uses dark oxygen could even help in developing therapies for conditions requiring low oxygen environments or in advancing cryogenic preservation technologies. Dark oxygen could also prompt a reevaluation of chemical bonding principles. Unlike regular oxygen, dark oxygen might form bonds that defy our current models, creating new types of compounds. These compounds could open avenues for creating materials that are stronger, more flexible, or even self-healing, making dark oxygen a frontier not just for biology, but for material science as well. As we explore dark oxygen and its potential to support life, we must also consider ethical implications. If we find life forms that rely on dark oxygen, how will we interact with them? Scientists and policymakers would need to set protocols for studying these organisms without disrupting their ecosystems or exposing Earth's biosphere to unknown risks. This discovery could drive new discussions on how to responsibly study alien life forms. Dark oxygen has the potential to captivate the public and inspire a new generation of scientists. Just as black holes and quantum mechanics sparked interest in physics, dark oxygen could spark curiosity in chemistry and astrobiology. Schools and universities might develop courses around these dark elements, expanding educational content and encouraging more students to pursue careers in science. The discovery of dark oxygen might lead to breakthroughs in other cosmological mysteries, like dark energy and the expansion of the universe. If dark oxygen shares properties with dark matter, it could provide insight into the structure of galaxies and the forces at work on a cosmic scale. Understanding dark oxygen could become a stepping stone toward a unified theory of dark matter, dark energy, and potentially other dark elements. In the future, dark oxygen could become as central to space exploration as rocket fuel and spacecraft materials are today. By learning to detect, study, and perhaps even utilize dark oxygen, humanity might find itself on the cusp of a new space age. Imagine a universe where dark oxygen-based life is not only a possibility, but a reality where we're no longer searching for alien life, but coexisting with it. This discovery could redefine humanity's place in the cosmos, challenging us to think beyond our current boundaries and embrace the vast hidden potential of the universe. If dark oxygen is a real phenomenon, it could hint at the existence of parallel universes. Some theories in physics suggest that other universes might operate under different laws of chemistry and physics. In such universes, dark oxygen could behave as a dominant molecule, supporting life in ways unimaginable to us. Exploring this idea could open a whole new realm of scientific exploration, where we not only look at other planets for signs of life, but also think about alternate dimensions and universes that may harbor life forms built on different scientific principles. Artificial intelligence, AI, could play a major role in the research of dark oxygen. With its ability to analyze massive data sets quickly and recognize patterns that human researchers might miss, AI could help scientists detect signs of dark oxygen on distant planets or moons. Additionally, AI algorithms could simulate the behavior of dark oxygen in various environments, helping to predict where it might exist and how it might support life. This synergy between AI and space research could accelerate our understanding of dark oxygen, bringing us closer to uncovering life in the universe. The search for dark oxygen could spark new technological innovations. As scientists develop new methods for detecting and understanding dark oxygen, they may create cutting-edge tools that have applications far beyond space exploration. These might include new sensors for medical use, innovations in energy storage, or even advances in materials science. Just as the space race led to everyday technologies like GPS and satellite communications, the quest for dark oxygen could result in breakthroughs that improve life on Earth in unexpected ways. If dark oxygen is found in various environments across space, it could drastically change how we approach space travel. New spacecraft could be designed with the ability to travel to places we once thought too hostile for human exploration. Understanding how dark oxygen might affect planetary environments would be crucial in preparing astronauts for long-duration missions to planets and moons that could harbor life forms based on dark oxygen. These advances could make deep space travel safer and more efficient, bringing us closer to interstellar exploration. As humanity looks to the stars for future colonization, dark oxygen might hold the key to sustainable life on other planets. If dark oxygen can support life in extreme conditions, it could be used to create life-supporting systems on other worlds. Colonists on Mars, for example, might learn how to manipulate dark oxygen to provide breathable air or energy in environments where traditional oxygen is scarce or absent. This revolutionary approach to life support could make space colonization more feasible and accelerate the timeline for establishing human habitats on distant planets. Dark oxygen challenges our understanding of the visible universe. Traditionally, we have based our view of the cosmos on light and what we can see, relying heavily on telescopes and other light-based instruments. However, dark oxygen forces us to consider an invisible universe, one that operates outside the realm of visible wavelengths. This new perspective could inspire a complete overhaul of how we study the cosmos, leading to the development of new methods of observation that can detect phenomena beyond the electromagnetic spectrum. One of the most exciting questions that arises from the discovery of dark oxygen is whether it can be synthesized on Earth. Scientists could potentially recreate conditions similar to those found on distant planets to produce dark oxygen in laboratory settings. By doing so, we could study its properties in detail and better understand how it might support life. The ability to synthesize dark oxygen could open up new scientific fields, from astrobiology to quantum chemistry, with profound implications for both space exploration and Earth-bound technology. Astrobiology, the study of life in the universe, stands to be one of the biggest beneficiaries of dark oxygen research. As we expand our understanding of what constitutes life, the discovery of dark oxygen may lead us to rethink the foundations of biology. This could prompt new research into how life can adapt to environments that were once thought inhospitable, pushing the boundaries of what we know about life's potential and where it might exist. Dark oxygen could redefine what scientists are looking for in the search for extraterrestrial life, broadening the scope of astrobiology far beyond our planet. Understanding how dark oxygen behaves in the atmospheres of exoplanets could provide crucial insights into the viability of these planets as hosts for life. For example, planets that are too far from their stars to have liquid water may still be able to support life if they have an atmosphere rich in dark oxygen. This discovery could redefine what makes a planet habitable, prompting astronomers to reconsider how they assess the potential for life on distant exoplanets. In the future, the presence of dark oxygen could be a signpost for habitable environments. The search for Earth-like planets is largely based on finding planets in the habitable zone where conditions are similar to Earth's. However, dark oxygen forces us to rethink the very definition of an Earth-like planet. A planet that doesn't meet the traditional criteria for habitability may still harbor life, particularly if dark oxygen is present. This could change how astronomers prioritize exoplanet targets, leading to a broader search for life and potentially more planets that could sustain dark oxygen-based life. Dark oxygen's unique properties could potentially have profound implications for bioengineering on Earth. If scientists learn how to replicate dark oxygen's chemical interactions, we might be able to design bioengineering processes that are more efficient or adaptable to extreme conditions. For instance, creating organisms that thrive in environments with low oxygen could be key to solving problems like climate change or food scarcity, as they could be used in industrial applications to break down pollutants or create more sustainable agricultural practices. Dark oxygen might be linked to the quantum world in unexpected ways. The strange, non-intuitive properties of quantum mechanics could explain how dark oxygen operates in such extreme conditions. For example, dark oxygen may exhibit behaviors like superposition or quantum tunneling, which could allow it to exist in multiple states or travel through barriers that would be impossible for regular oxygen. Understanding these quantum properties could lead to groundbreaking advances in both space exploration and our understanding of the universe. Dark oxygen could also play a crucial role in the evolution of galaxies. If it exists in the atmospheres of stars or the interstellar medium, it could influence the chemical makeup of galaxies, potentially affecting the formation of stars and planets. The discovery of dark oxygen might reveal that the ingredients for life are more widespread than we think, contributing to the growth and evolution of galaxies in ways we haven't yet imagined. One of the most profound implications of dark oxygen is its potential to broaden our understanding of life across the universe. If dark oxygen supports life in environments we cannot yet detect, it would suggest that life could be ubiquitous in the cosmos, but in forms entirely alien to us. This would change our perspective on life's existence, moving away from the Earth-centric view and instead proposing a universe teeming with life, but hidden in ways we are only beginning to understand. The discovery of dark oxygen has the potential to challenge philosophical ideas about life, consciousness, and the nature of existence itself. If life can exist in forms completely different from what we consider normal, it raises profound questions about the limits of life and intelligence. Are we as humans the pinnacle of biological evolution, or is there a much more diverse array of life forms out there, hidden from view? The search for dark oxygen could push humanity to rethink our place in the universe and our understanding of what it means to be alive. Dark oxygen will undoubtedly shape the direction of future scientific research. As scientists begin to probe its existence, they will develop new methodologies and technologies that could change the way we approach all forms of science. From space exploration to chemistry and even biology, the impact of this discovery will reverberate throughout many disciplines, leading to a more holistic understanding of the universe and the life that may inhabit it. Imagine a future where dark oxygen plays a central role in intergalactic communication. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.